So this video gives an overview of data and databases. So let's just discuss the importance of data. We use data in every corner of our lives. Just some examples here: banking, education, healthcare, research, manufacturing, forestry, logging, government. All right, so when we talk about the Industry 4.0 and digitizing information, this is meaning that we're collecting this data. So this is critical. And so we're trying to digitize pretty much every aspect of the business, of the manufacturing. And so the Industry 4.0 is not just about storing data about how many widgets or parts that we're producing in the last 24 hours or in the last month or whatever. But what we want to do is collect this data and then be able to analyze the data and work with the data. And so that's where we need an actual database. Okay, so this is just an overview of the IIoT structure that we looked at before. And so remember, down here at the bottom is where our production equipment is at. We're running real-time machines, sensors, actuators, all of that. That data then is being passed up through the gateway device to the internet and into storage, meaning the database. Okay, so the database is where we're going to store that data. Now that could be up here in the cloud as it shows in this drawing, or it could actually be done down here more at the local side. So when we talk about storing data, we have to understand what type of data is actually being stored. Okay. So like the words Industrial Internet of Things, okay, that's known as text or character type data. A number can be a numeric value, such as like the number 3 could be an integer, or we could have a whole number or a real number, a whole number is an integer, but we can also have a real value. So here's some different examples. One of the big things that we do when we store information is we want to also store the date. So we can store just the date, or we can store a date time value, or we could just store time also. We can also store like Boolean information, whether it's just true or false. We can store names as either characters or variable characters. Now the difference here is if it's a varchar, that means that the length of it is variable. So if you have a char type, you're saying that maybe I have 25 characters and that's the absolute max that I can put there. But with a varchar, I'm saying that it could be 5 characters or it could be 500 characters. So it gives us the ability to make the length of it flexible. And then we have a bit, which is like a Boolean, only instead of Boolean is true or false, the bit would be a 1 or a 0. And then of course our integer value, and then our floating point or our real value, which contains a decimal point. So these are the primary types of data that we would want to store in our database. The one thing not mentioned on here would be if we wanted to store things like images or videos, then those would be loaded as usually what they call blobs, which stands for binary large object. So the data, I'm going to say, the information is our data, and we're going to store that in a database. So the database technically is a software program, and it's kind of more of a general term. We call it a database, and it's a software program, and a lot of times the official name for that is a DBMS, or database management system. So we have most databases are what we call relational database, meaning that all the data in there is organized and then related to other data through the use of what we call keys or links. And so a table, here's an example of a table. So a table is pretty much identical to a spreadsheet. So if you're familiar with like a spreadsheet in Microsoft Excel, right, you have the spreadsheet where you have rows and columns of information. So the table is made up of what we call fields or columns. And so we identify those columns, including we give them a name, and we also give it a data type, whether it's a character string or like a student ID. A lot of times a student ID value here is just a unique identifier number, so it'll be an integer. There's no point for a decimal point or a real value there, just a whole number value. And then we have things like zip codes, which again are just like integer values. And then we have character data that we can store in there. So we can have like the state. We could use the 2-digit state code. So this character field only needs to store 2 digits, but like a city, can it be different lengths? All right. Now the rows here are called records, and the columns, as I already mentioned, are referred to as fields. So what we do is typically what we'll do in a table. So the table is the different is kind of like the entire spreadsheet thing, if you want to think of it as a spreadsheet. Okay, and so we have the columns. Columns are fields, and those are basically different classes like first name, last name, social security number, whatever kind of information that we're going to store in there. And then the actual rows are the different records. So in this case, this is a student database, and so each record or each row represents a different student. All right. So what makes this relational is the fact that you have one table can be linked to another table, which is then linked to another table, and so there's a relationship between each table. And this is the huge difference between a spreadsheet and a database. Okay, so like I say, if you look at this here, we could do this in a spreadsheet, no problem. We could create this student spreadsheet here and have our student ID and the names and their addresses. But the problem is that students can have, say, different addresses. For one thing, they can have maybe a home address, and then maybe they're living in an apartment, so they have like a temporary address. They can also have like a work address, right? So that one student can have multiple addresses. Same thing is that one student, we don't have in this table a telephone, but a student can have multiple telephone numbers. They can have like a home number, they could have a work number, and they can have a cell number. And so you can have multiple telephone numbers associated with that student. And so to organize that, what we do is we break up the data where you're going to have maybe multiple addresses or multiple telephone numbers into different tables, and then we link them. And again, this is the huge difference between a spreadsheet and a database. A spreadsheet, it's all just right there in one table, but if you have like three different addresses or three different telephone numbers, then it just starts getting unwieldy. Where a database, you break those into different tables and then you link those together using their relationship. All right, so these relationships are usually set up using keys. So we'll have like a primary key, like a student ID. So, like at Stark State, right? When you apply to Stark State and you're accepted, you are issued a student ID. And that then is then used in our link for our registration database to link that ID to your information in the rest of the database. And we really need that ID because that ID is a unique ID, because a lot of times, you have a name that, names sometimes are very, very common. And so you might have somebody say Mike Miller or something. That's Miller is a very, very common last name, and so we might have multiple Millers in our database. We might have over 100 Millers in our database. And then Michael is also a fairly common first name, and so we might have 5 or 6 different Michaels, maybe even more than that, Michael Millers in this database. And so if you're trying to look up a student based on just the name and they have a more of a common name, there might be multiple matches. So it's like, how do I know which one I'm looking for? And that's where we have the student ID, which is unique. So that's called a primary key. So the primary key must be unique. All right. So then we have a second table. So in this case here, on what we have is we have a device table where I have multiple temperature sensors, and they're placed in different places around the house. And then we have a data table, which is taking data from these temperature sensors. And now notice over here in the data table, it doesn't tell us where the temperature sensor is. That information is stored in the device table. And so what we have then is we have a device ID, which is linking the actual temperature data back to the device table, which tells us the location and the serial number of the temperature sensor and whether the temperature sensor is active. Okay, so we have the primary key for the device table is you have multiple devices. So in this case I have 3 devices and I just start numbering them, the device 1, device 2, device 3. And then I have data. My data information has a data ID, which is just kind of a unique record. And then I have the device ID, which is my link. So in the data table, the device ID is our secondary key. And so it can be repeated in the data table. So you see here I have device 2. I have 2 temperatures for device 2, and they were taken at different times, right? And so, therefore, if I'm collecting data, multiple times a day, I can have hundreds or thousands of records for device 2 in the data table where I'm collecting the temperatures. And then I can link that, so I can do a search and say, I'm looking for the temperature for the back patio at a given time or within a given time range. Say, show me the temperature range, show me all the temperature readings for the back patio temperature sensor for the past 24 hours or things like that. So this again, this is where we have a database is so different and so much more important than a single spreadsheet. So, if you look at the device table, it kind of looks like a spreadsheet. Data table looks like a spreadsheet, but the link between these two is what makes it a database. It's that relationship. Okay. So foreign key is the device ID. I think I called it secondary key. The official term is foreign key for that. So that's the device, which I already talked about. And so now when I want to query my database, right, I can join the two tables together to do a query. So I can say, okay, I'm looking for the back patio, and I want this date and time range, and I want, or maybe I'm looking for temperatures. So I'm looking for various different temperatures or whatever kind of information there is there. Okay. So when we build a database, okay, one of the aspects that we have to keep in mind is security. So we might have certain tables. We don't want just anybody or anything to be able to change. Other tables, like the temperature database, the temperature table, the data table that's holding the temperatures, each sensor, is uploading those temperatures, and so somebody has to have the authority to insert the temperature into that table. But the other table, the device table, maybe you only want one person or one or two people that are allowed to add new temperature sensors or new devices. But once you add those devices then need to be able to upload their new temperature readings into that. So you have different tables might have different access. Okay. So typically what you'll have is what they call a database administrator, abbreviated DBA, or sometimes they give them the name database architect. And they're kind of in charge of setting up the database and setting authority on who's allowed to write what data where, or who's allowed to query the data. So we have a language called SQL, or Structured Query Language, which is designed to query the database. Okay. And so the idea is that we can, with this, we can run queries and pull the information out of the database. And a lot of times we talk about SQL including the ability to create or modify the database, although technically that's an expanded, SQL technically is only for querying the data, and we call it database markup language to actually edit and update records and modify the entire database. So we have DML, stands for Data Manipulation Language. This is the ability to insert new data into a table or multiple tables, or update data already in the table, or delete the data. And then DDL, which stands for Data Definition Language, which are commands or ability to actually create tables, drop tables or remove tables, or to alter them, add fields to them. All right, so the DDL, like I say, is where we can actually create the database, create tables within the database, we can create the primary keys. Okay. One of the things that you might want to do is to drop a table. All right, and so like let's say that you want to import some data. So you had the database, and then you want to kind of import into it. So we can use this like option here to say drop table if it exists. And so we're going to drop the table data if it exists. Okay. And the difference here is if you don't use the if exists and it doesn't exist, then the instruction will fail and then it'll stop running. But if you use the if exists, then if the table doesn't exist, it'll continue to run. So you can actually create scripts that can build these databases or modify these databases on the fly, and you do step 1, step 2, step 3, step 4, and you just continue on. All right, so you can alter a table, you can add columns. Okay, we can select data. So this is the select, or the select is kind of the structured query language piece here, where you can select which fields that you want from a table, and then you specify what table. So when you do a select, you have the select saying, I want to select some data from one or more tables. This is just one table in this case, but I want to select, and you can select which fields. So if you wanted all the fields, you could actually put an asterisk there and say select star from, and then the name of the table. And then notice the semicolon. So the semicolon terminates any of these instructions. You have to have that semicolon to finish the instruction. You also, if you're selecting individual fields, you separate those with commas. Okay. So in this case here, we're just selecting the data ID and the value fields from the data table, which has the temperatures. Here we're doing a select star. So as I mentioned before, the star says give me all the fields. So I'm selecting all the fields, and it's going to give me all the fields with all the records in the table from the data table. Now, if we want to limit the data we're getting, we throw in a where clause. So notice anytime you do a select, you always have a from, but then the where is optional but highly recommended. So here I'm going to say I'm going to select all the fields from the data, but where device ID is equal to 2. So I'm only retrieving, this is going to retrieve every single temperature from the data table if the device is device ID number 2. And this is where it allows me to limit it to just say the temperature from that back patio sensor. All right. We can also throw in an order by, and we can order it by the date and time. We could order it by, say, the temperature value, or the data ID value. Okay. So you can select an order by, and you can actually put multiple ones, and so it'll order it in the number. So I have like the insert date time, and then by, say, temperature or whatever. So I can put multiple ones. I'd separate the different field names with commas. All right. Now for inserting the data, so remember, we're collecting the data from a temperature sensor, and then we want to upload it into the table. So we use an insert statement to do that. So we insert into the data table. We need to know the data ID of our that we're going to put there. Now remember, data ID was just a unique number. So one option there is to actually just tell it auto increment, and then it'll just like add and the next free number on there for the data ID. But we do need to know the device ID, and then the actual temperature value, what the units are, because we have the units in the table, and then the insert date time, which is going to be the current timestamp that we're inserting the data into the database. All right. Now, if the data is already in there, but you need to update it to say that maybe when you did the insert, you had the units wrong, then you could use an update command to update that temperature. All right, and as I mentioned before, you can do all these different commands plus a lot of more that I really didn't cover, and you can create a script to import or to insert the data into the database or make changes to the database. So you can create a script to do that. Now that script then you can actually set up as what we call a stored procedure. So the stored procedure will actually be stored in another table, and then you call that stored procedure to perform the script of instructions every time data is uploaded, or whenever you want that to be called. So you would then call that stored procedure or that script. All right, when we're doing a query, we can join the tables by linking a primary key to a foreign key in the other table. And so here's a case where we're doing a join. They have what they call inner joins and outer joins. Inner joins are the most common here. And with an inner join, what we're doing is we're saying we're going to select from two tables now, not just one table, but two tables. And so we have our data table, which has the actual temperature data. And then we have the device table, which had the location of the temperature sensor. And so we select from two different tables. So our from now, instead of just saying data table, it says from the device table joined with the data table, and our joining mechanism is the device ID field, which exists in both the data and the device ID, or in the device table. So here we can just do a much larger example of a database. Okay, and so this here we have, what we've done is we've broken the data up into kind of smaller pieces. And again, the reason we do this is because it will minimize duplication of data in different tables. So like the location of the device, right? So here's our location of the device. We don't want to put the location of where this temperature sensor is at more than once. Okay, so like if we just had one spreadsheet and we were collecting the temperature data, then but we also want to know where it's at. So inside of that spreadsheet, we would always have to keep saying, okay, well, it's the location is in the on the back porch or whatever it is. And so we'd have to keep putting that in every time we added a new temperature reading. So the idea is that you organize the data and put them in different tables, and so you don't repeat it. So it saves a ton of disk space by organizing and creating multiple tables, and then when you do your query, you link in the different tables using like the inner joins that I just showed you, so that you can pull in the parts that you want for your particular query. Okay. Now, there's lots of different database systems out there. One of the biggest, probably the biggest, is Oracle. Oracle is a huge database system. Another very, very popular one is called Microsoft SQL Server. Very, very, very commonly used database. Now, the thing is with the Oracle and the Microsoft SQL Server, these are very expensive, very complex, proprietary type databases. A lot of times for simple stuff, people use MySQL. MySQL is a free version of a database. It's not quite as robust as Oracle or SQL Server, but it is quite robust, and it's free to use, and it runs on virtually any type of system, including our BeagleBones. Okay. Now, actually, the version running on our BeagleBone it's MySQL, but it's named Maria. Okay. But what we're going to do, let's say we have a lab that we can actually query a database using Node-RED and pull the data out. So what we have to do is, if we're going to do this in Node-RED, we would have to make a connection to the database server, because remember, the database server is this whole separate program. So you got to have the database server running, and then you would connect to that database server, and then you would do a select to retrieve the data. And then from there you could filter the results and display it in the dashboard. Okay. Now they also have come out with some new databases that are not fully dependent on SQL. So like if you look at the three that I just had there, MySQL, Oracle, and SQL Server, Microsoft SQL Server. It's how they usually pronounce it, as SQL. Those are SQL databases, which means they use that structured query language that we just went over to interact with those. And the structured query language, again, is so awesome because it allows you to do these inner joins and do these relationships between your multiple different tables. But sometimes, like if you think about like when you go out to Google and you do a search, the SQL is a little bit too structured, and it won't maybe give you everything that you're asking for. And so they've started coming out with these, what they call NoSQL or NoSQL, where the NO actually stands for not only SQL. So most of these types of databases can actually also do SQL, because SQL, there's certain times where SQL is what you definitely want. But sometimes you need something more than just the SQL so that you can kind of query in other areas. And so that's where they're starting to come out with, or they have come out with, these not only SQL databases that allow you to do some more general queries and selects. Okay. So here I just name a few of these. Google created one called Bigtable. Apache has one called HBase. Okay. And so again, the idea here is that these are available, and they can use SQL when it's appropriate, but they also have the ability to do searches through the database without structured query language. All right, so what's the advantages and disadvantages of these NoSQL systems? All right, as I mentioned, the advantage is that sometimes you're working with data that maybe is not quite as structured, and so that's a big advantage. Okay. But a lot of times your data is highly structured, especially when you're talking about, oh, I have all these sensors collecting temperature data. That is extremely structured, and so SQL works very well for that. Okay. All right, that's it for the database video.